Okay, so I usually start off with this example in such kind of introductory courses. So if I were to ask you if you can read this statement, so please let me know in your comments. Otherwise, this is a sentence which is written in Korean language. So I'm assuming that you're not familiar with the Korean language. So what do you need to do to decode this statement? Let's say we pass this statement through a certain process, and after processing, the main Korean sentence may be translated into something like this. Now, this transformation is a little bit helpful in a sense that you can at least now read this, but you may not still be able to understand this. So, how would you read it? It says pronounced like 안녕하세요, 죄벌 잠들지마, which means that we still have to pass through this another process. And after passing through this procedure, I promise that you may be able to not only read this, but also be able to understand this. So there you go. So this main Korean language translates into a hello, please do not fall asleep. And this message goes for you also. If you're watching these videos, please do not fall asleep. I'll make sure to make these lectures as interesting as possible for you. So as same as the example I have just given you, computer also has a specific language which it understands. So nowadays you can easily communicate with computers using a high-level language. For example, a statement like this. So you can write something like A equals B plus C plus D, which you think computer may be able to understand. But this is not. This is only a human-friendly way to give instructions to computer. To make it understandable by a computer, we need to transform it into a language which a computer understands. And that is called a machine language, which comprises of numbers only. So what you type at the high level language is called the human understandable language, which you think you're communicating with a computer, which could be any programming language, but computers still do not understand it. It has to pass through a couple of different procedures in order to be translated into something which a computer understands. Okay, and that is a language of numbers. So if I were to tell you about the design hierarchy, so what you write is a very high level language code. It could be any programming language. This is something, this would something look like this. So this high level language code is translated into something called assembly language with the program or with the procedure called compilation. Okay, so the program called compiler would translate a high level language code into an assembly language code. This assembly language code is then translated into a machine code with the help of a program called assembler, and this is what we call number representation, or the machine code, which a computer understands. Now the computer understands only the language of ones and zeros. Now what are these ones and zeros? So these ones and zeros are nothing but a voltage levels. Okay, it could be high level voltage, it could be 5 volt, or low level voltage 0 volt. Now these voltage levels, you supply a power, and these voltage levels are controlled by an electronic components which we call digital logic gates. Now again, if you go further deep down, these digital logic gates are composed of another lower level electronic components called transistors. And then these transistors are then fabricated with the help of a material called semiconductor. Okay, so this is the lowest level of implementation of an electronic circuit, or in other words, a computer. Okay, so this is the design hierarchy in the form of flowchart. So what you write is a high level language code, which is translated into assembly code, and then a machine code, which is then implemented with the help of logic gates and transistor level circuits. And these transistor level circuits are fabricated on semiconductor material. So out of this entire design hierarchy, the focus of this course is the high level language. So let's talk about some computational thinking. So I'm sure majority of you must already be aware of this smart guy named Stephen Hawking. So he had one of the worst medical condition one could ever imagine, which is called locked-in syndrome. So it leaves your all mental abilities intact, but totally paralyzed, except that you can only blink your eye. So God forbid that happens to anyone, but just imagine one fine day you wake up and found yourself in the same situation where you can see, think, even feel, but you cannot move. You cannot speak. All what you can do is to blink your eye. So your intelligent mind is locked inside a useless body. So it could happen to anyone as a result of a stroke. So to help people in such a situation, you can of course either become a nurse or a doctor. But now since you are with being here as a part of a CAS program, so what do you think you can do to support or help a person with locked-in syndrome? Just give a pause and think about anything that you can come up with as a CS computer scientist. Okay? How do you think you would be able to communicate with the person around you? Just think about any ideas. Or let me proceed ahead. Just pause the video for a while and then come up with the solution. Or if you want to just keep me going, just 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 keep the video going. So person with this syndrome can come up with an idea of communicating with the patient. So simple as ABC. So for example, if you would like to communicate, if you're in a situation like a locked-in syndrome, you would want to consider communicating simple alphabets like A, B, C. So what you need to do is to have some kind of like agreed way of turning blinks into letters, blinking of your eye into letters. So your first idea might be to consider one blink as letter A, two blinks as letter B, and so on and so forth. So in coming up with this idea, you have already done computational thinking. So in particular, we have done a form of algorithmic thinking. So a computer scientist would call it as an algorithm, which is essentially a series of steps to follow to achieve a certain result. So once you tried out the first ever approach to come up with a solution, you may realize that the problem is even bigger than what you initially thought. So there are spaces, digits, and punctuations to be specified. So on your way, you might also be thinking that there might be some more smarter ways to solve the problem. In other words, improving the algorithm. So we can come up with a list of characters and consider adding those as they come along. And also agree on where do they appear in the list. So we may consider developing a table or a list where we can keep on keep on including new values whatever as they come in. So we have to standardize the list. So do you know any example of such a standards in computer science which are developed and followed worldwide? So we are also thinking of developing a standard, but there is a standard that already exists for like standardizing the representation of some letters like A, B, C, D, and numbers and all that. So these are called ASCII characters, American Standard Code for Information Interchange. Okay. Now, of course, we need to organize lists in a way that we can get to the required values as fast as possible. And this depends on how the data is structured and organized. So this is where the terminology of the data structure comes from. It is very important how the data is structured, which helps the algorithm to solve problems efficiently. We will be talking about this later, but let's move on to the next slide. So what is a computer program? A program is simply like a recipe. Some people think of a program as being like a cooking recipe. A recipe consists of instructions that a chef executes, like adding eggs or stirring ingredients. So for example, like baking chocolate chip cookie from a recipe, it would require mixing one stick of butter and 1 cup of sugar, and then add egg and mix until it combined. Stir in flour and chocolate, baked at 350 Fahrenheit for 8 minutes, and voila, you got a cookie. So the computer program likewise consists of instructions that a computer executes, like multiplying numbers or outputting a number to a screen. So it follows a series of instructions, series of steps in order to execute a certain task. So programming is a way to tell your computer how to perform tasks by giving specific instructions, and which we have already discussed, which is known as algorithm. So a computer program is an algorithm that is understandable and executable by a computer. So some famous computer programs are the Microsoft Windows, Instagram, Facebook, Google Mail app, and all that. Okay, so let's try doing an activity here. So the purpose of this activity is to develop a digital system in which you are supposed to develop a system which turns on the cooler after a delay of 1 second, and when a button is pressed, so it should turn on the cooler after a delay of 1 second, or once the system reaches above the predefined temperature. So just assume that you are turning a temperature controller, turning on the temperature controller in your own house. So if you're living in the United States, you must already have that piece of device, especially if you're living in the northern areas. So if you forcefully turn on the temperature controller, AC, it turns on the cooling. Otherwise, if you keep it turned on and set the temperature, so if the temperature inside your house, for example, if it reaches beyond its certain value or threshold value that you have set, so maybe for example 72 °F, or let's say if you talk about the degree Celsius, if it is set to like 25 °C, so if the temperature rises above the set value, then the system should turn on. So this is what the activity is about. You're supposed to be developing this activity. So just to elaborate further on this, so you have the specifications, like inputs is a power button, manual cooler control, temperature sensor, and temperature set control. So this is the power button. If it is turned on, the digital system will only work if the power system is on. Okay. Then we have the manual fan control. So manual fan control is a button which you would use to manually turning on the fan. And then we have a temperature sensor, which would keep sensing the temperature of the surrounding, of the environment, and the temperature set control. This is where you would be setting a temperature. So you may consider these the interface on the left hand side as an input interface. Next we have the output, the power indicator. So when the power is on, this should show that the system is turned on. And then we have the cooling fan, which is the output of the entire system. So let me give you a little bit of demonstration here. So for example, if you press the button, okay, so the system should also work only when the system is powered on. So everything, whatever you are going to develop, it should only work when the system is powered on. Okay, so when you click on the power button, the power indicator should show that the power is on. Now another thing is what you could do is you can manually turn the fan on. So after a delay of 1 second, the cooler should start running, the fan should start running. Okay, maybe because it is not exactly appearing as I planned it to appear because of I'm recording this video. That might be the reason. Anyway, so I can turn this off and it should turn off the fan. Okay, now the other thing is if the temperature rises above a certain threshold, let's say for example if it reaches above the 50 °C, the cooler should turn on automatically. Okay, so this is the activity you're supposed to do. I'm posting this activity as a in a PDF format, so you can take a print it out, and or if you're attending a lecture with me right now in person, I would be providing you this activity sheet. So just think about this system as a box, and just write the instructions inside this box what you're supposed to be doing. So the specifications are in front of you. Your system should only work when the power is on, and the fan should turn on if you manually turn on the fan control switch, which is a toggle switch. Or another condition is if the temperature rises above a certain threshold. Let's say in this example, if the temperature rises above the 50 degrees Celsius, then the cooler should turn on. Okay, so give it a pause here and try to write the instructions at your own on this activity sheet. I will clear the solution, discuss the solution in the next video.